This is the electrocardiogram of a 62 years masculine at rest. If you think that you can do the interpretation of this electrocardiogram, stop the video now and then continue to see if we have the same conclusion. We are going to begin with the calibration. Here are two small squares, and two small squares are 0.08 seconds, so it's 200 millimeters over 8 seconds. If we divide all over 4, it's 50 over 2, so it's 25 millimeters in 1 second. And the height of this rectangle is like 10 small squares, which is 1 millivolt, so the calibration is normal. The frequency, if the next bit would have been here, it would be 300 over 1. If the next bit would have been here, it would be 300 over 2. If the next bit would have been here, it would be 300 over 3. If the next bit would have been here, it would be 300 over 4. If the next bit would have been here, it would be 300 over 5. If the next bit would have been here, it would be 300 over 6. So here are 30 small squares plus 2 is plus 3, so here 2, and here is 1, 33. So instead of do 300 over the big squares, we are going to do 1050 over the small squares, which are 33. So 1500 over 33, which is 45, and is below 60 beats per minute, so is bradycardia. Now we are going to see the read. The P is positive in D1, D2, D3, and in ABF, and it is negative in ABR, and the morphology of the P is the same in the same derivation. So the read is a sinus read. The PR is from the beginning of the P to the beginning of the QRS. Here are like two small squares plus others 2 or 1.5 is like 4 or 3.5, so it's like 0.16 seconds, and is not abnormal because it's between 0.12 and 0.20 seconds. The axis of the QRS is between D1 and D2 because this derivation have the highest R, so it is like in 30 degrees. The axis of the P is in D2 because it's a derivation which has the highest P wave, and is not abnormal because it's between D1 and ABF, so it's between 0 degrees and 90 degrees. Now the hypertrophy of the right ventricle is that the R of V1 has to be greater than 7 small squares in amplitude, which is 0.7 millivolts, and that the R be greater than ds in V1, which is not, so there is no right ventricle hypertrophy. The left ventricle hypertrophy is the S of V1 plus the R of V5 or V6, the one who is greater, so it's 5 plus 1 is 6 plus 3 is 9 plus 5 and 3 is 8 plus 1.5 is 9.5 plus 9 is 18.5, which is 1.85 of millivolt. So there is no right ventricle of the left ventricle hypertrophy. Now the hypertrophy of the left atrium is that the width of the P wave has to be greater than 3 small squares, which is 0.12 seconds, and here is like 2 and a little more, like 0.1 seconds. So it is less than 0.12 seconds, so there is no hypertrophy of the left atrium. The hypertrophy of the right atrium is that the P in D2, D3 and ABF has to be less than 0.25 millivolts. So in D2 it's like 1.5 of small square, so it's 0.15 millivolts. In D3 it's like 0.1 millivolt. In ABF is like 0.5 millivolt. So there is no right atrium hypertrophy. Now the right bundle branch block is that there is R, S, R prima in B1 and there is no R prima, and in B6 there is no S, so there is no right bundle branch block. In the left bundle branch block we have a QS complex in B1 which is not, and we don't have Qs in B6 or B5 which are, and the shape of the QRS, the morphology, is like an M which is not, so there is no left bundle branch block. Now the width of the QRS is from the beginning of the Q or from the beginning of the R if we don't have Q to the end of the S. Here is like 1.5 millivolts. Here, so it's 0.06. Maybe here is a little less. Here is like 0.08 millivolts. So it is not abnormal because it is less than 0.12 milliseconds, 12.12 seconds. The QT is from the beginning of the QRS to the end of the T. So it's like 3 plus 5 is 8 plus 3 is 11 over the distance from R to R, which is 5, 10, 15, 20, 25, 30, 30, 31, 32, 33. So is in seconds is 33 times 0.04, which is 1.32 seconds. Then the root, and then is the QT, which is 0.44 because are 11 small squares over the root of the distance from R to R, which is 0.38. So the QT is not abnormal because the QT is less than half the distance from R to R. And then the U wave, it has to be less than 1/4 of the T. So here it is like less than 0.1 of millivolt, and the T wave is like 3 and 3 is 6, so this is normal. Here is like almost 0, so obviously yes, and here is almost 1, and the T wave is a little more than 0.5 millivolts, so it is normal. The amplitude of the U wave, and normally is less than 0.15 millivolts, but that's just normal. The transition is between B3 and B4. It is closer to B3 because here the QRS is negative and here it is positive. Now the concordance of the QRS with the T wave. The T wave is positive and the QRS is positive in D1. In D2 both are positive, so these two leads are concordant. Here the QRS is negative and the T wave is positive, so in D3 is discordant. In ABR the QRS is negative and the T is negative, so this is concordant. In ABL the QRS is positive and the T wave is negative, so this is discordant. In ABF the QRS is positive and the T wave is positive, so this is concordant. In B1, B2 and B3 the T wave is positive and the QRS is negative, or more negative, and there is discordance both in these leads that is allowed. In V4, V5 and V6 the QRS is positive and the T wave is positive, so these three leads are concordant. So the diagnostic is that there is sinus bradycardia. Studying the next ECG.